Hey guys, welcome back to the channel. Today we'll be solving LeetCode 763 partition labels. So we're given a string S and we want to partition the string into as many parts as possible, but each letter can only be seen in one part. So for example, if we partition a certain segment such as this, into 9 different characters, and A occurs in this segment, A is not allowed to occur in any other segment. And for example, D occurred here, and we have to stop until here. And basically, D can't occur in any other segments that we create. So, for example, if we had every letter from A to Z, so every letter in the alphabet, A, B, C, D, F, G, all the way to Z, then we could have 26 partitions with each being a length of 1. And the way we want to output this is we want to put the length of each partition as an integer in the array. So in this case, we have 3 partitions and each of them have a length in this array, 9, 7, and 8. And for this one, let's go through this one as well. So we have E, and the last occurrence of E is over here. So we try to see if we make this a partition. No, we can't, because we have C over here. So we can't make this a partition since C also occurs over here. So if we were to make this a partition and this a partition, it wouldn't work because C is also out in another partition. So this would be one big partition. So we can solve this efficiently in linear time, or OVN, and with constant extra space with a hash map. And we're just going to pretty much storing 26 different entries, so it's going to be constant. And we can do it using a 2-pointer technique. So let's get into the explanation now. To solve this problem, we're going to have 2 parts. At the first part, we're going to create a dictionary that is going to hold the last occurrence of each character. The keys of the dictionary are going to be the characters, and the values are going to be the last index at which that character occurred in the array. So for example, the last index that A occurs is over here, and the last occurrence that D occurred is over here, the last occurrence that J occurred is over here, and so on and so forth. And this is actually going to be of constant space because we have 26 letters in the alphabet. So that's actually one of the reasons that this algorithm is going to have constant space complexity. And we're going to be having 2 for loops, and we're going to be iterating through the array twice. So we're going to have linear time complexity, or O of n. So to solve this, after we've created our dictionary, we're going to have 3 pointers. One is going to be an iterator, the other one's going to be a start pointer, and we're going to have a end pointer as well. So we can use blue for the start pointer, and then we're going to have a current iterator, and then we're going to have a end pointer. So initially, all of the pointers are going to be at the beginning of the array, and then at every iteration, when we check with the last occurrence of that character, we're going to set the end pointer to that location only if it's greater than what the end pointer is currently at. So A's last occurrence is over here, and that is greater than 0, which is what our end pointer is currently at. So we're going to set it to over here. And then we're going to keep the start pointer where it is. And the start pointer will only change in the case that we find one partition. And we're going to find the partition when the current iterator reaches the end pointer. So we're going to start iterating, and we're going to check B. The last occurrence of B is over here, but that is not greater than the end pointer, so we're going to keep it where it is. We're going to keep iterating. B is not greater, C is not greater, because the last occurrence of C is over here. still not greater. We're already at the last occurrence of A, not greater. And then these two reach, and then we realize that we can update our result array, and we can actually add the first partition, and that's going to be the end pointer minus the start pointer plus 1, and that's going to be a value of 9. And then we're just going to keep iterating, and before we keep iterating, we're going to reset the start pointer to the current iterator plus 1, and the end pointer can also be over here. And now we're here, we're going to check the last occurrence of D, which is going to be over here, and then we're going to start iterating, and we're going to see E. Last occurrence of E is over here, so we're going to move, and then we're going to keep iterating. Last occurrence of F, this is the only occurrence of F. Last occurrence of E, last occurrence of G, this is the only occurrence of G. Last occurrence of D, this is the last occurrence of D, and then we reach, and then we can append another one because these two pointers have met, and we can change this to 7. Then we're just going to keep iterating, but before we iterate, we're going to reset these pointers to the next iteration, and we're going to see last occurrence of H is over here, and we're going to keep iterating, and we see last occurrence of I is over here, so we're going to move it over here. Last occurrence of J is over here, and then nothing is greater than that, so we can just go to the end, and we're basically done. We can add our last integer to our result, which is going to be 8. And this is pretty much the entire algorithm. So let's get into our code now. So we're going to start by creating our last occurrence dictionary, and we can just do that like this in one line. So the key is going to be the character, and the value is going to be the index, and we're just going to loop using enumerate through the string. And then we're also going to store a result array, and we're going to have two pointers, a start pointer and a end pointer, that are both going to be initialized to the beginning of the array, or 0. Then we're going to iterate through the array one more time, and we're going to use enumerate again. Then we're going to see, does the current end need to be updated? And the only time we're going to update it is if the current one we're on, so that's going to be the last occurrence of the current character, which we can get using our dictionary. So this is going to get the last occurrence of the current character. If it's at a higher point in the array or further point in the array than our current end, then we're going to update end. And if the current iterator ever meets the end, then that means we have completed one partition, and we can append to the result array. And we're going to append the length, which is going to be the end minus the start plus 1. And after that, we want to reset our start pointer, which is going to be reset to I plus 1. And after all that, we're pretty much done. This is all the code. We can just return our result. This should work. Looks like it worked, and it's pretty efficient. It's going to run in linear time with constant extra space. Thanks for watching.